Hi everybody, today we're going to talk about consumer and producer surplus. So let's quickly think back to supply and demand. When you think about demand, generally we see that when prices decrease, the demand for the item increases. If you think about your willingness to buy an item when things go on sale versus paying full price. Now when we flip that around and think about supply, it's on the opposite side of the market. So higher prices encourage more suppliers to provide the service. Let's start with an example where I have the demand function for X thousand fitness watches can be modeled by the price P is equal to D of X is negative 0.2x plus 250. So I've graphed it and you can see that it has a negative slope. But what I want to do here is I want to find how many watches we can sell at a price of 150. So I'm going to set my negative 0.2x plus 250 equal to 150. So to solve this, I'm going to move the 250 over. I get negative 0.2x is equal to negative 100. And then I divide by negative 0.2, which is going to end up giving me a positive 500. Our graph displays what we found, that at a price of $150 per watch, we're going to sell 500,000 fitness watches. The green area would show us our revenue. It would be the price times the quantity. Now there's this extra piece above the graph, and that's what I really want to spend time talking about. The green area represents the revenue. The purple area above it represents the money people would have spent if the price wasn't $150. So what that means is there were people that were willing to spend $200 or $250. So as the price went down and more people bought, there was this area here where people would have spent that money if the price had been higher. So that's what we call the consumer surplus. The top triangle shows the amount consumers saved because the watches were $150. We call this area the consumer surplus. So let's look at a definition for a consumer surplus. The consumer surplus, which I'll abbreviate CS, is the difference between what consumers were willing to pay for X items and what they actually paid for X items. So we're going to let P bar be the price that the consumers actually paid for X bar items with this demand function D of X. Our formula will be CS is equal to the integral from 0 to X bar of D of X minus P bar dx. Let's go back to the picture so we can say, what does that mean? So we're really finding the area between two curves. What the consumers really paid, P bar, is my horizontal line. Then D of X, which is our demand function, is this slanted line. Now remember, we said when we're doing the area between the curves, we always put the function that's on top first. So there was dx. And then we put the second function after and we subtract. You can see we went from 0 to 500, so that was 0 to X bar dx. So let's try this specifically for the example we have. So we said we want to go from 0 to X bar. X bar is how many we sold, so that was 500. dx was negative 0.2x plus 250, and then we're subtracting the price, which was 150 dx. We can combine the 250 and the 150, so let's do that before we integrate. So I have 0 to 500, negative 0.2x, plus 100 dx. When I integrate, I'm just using the power rule. This is negative 0.2x squared over 2 plus 100x. I need to put in 0 and 500. If you want to, you could simplify first. So negative 0.2 over 2 would be negative 0.1x squared plus 100x from 0 to 500. So I need to put the 500 in. I have negative 0.1 times 500 squared plus 100 times 500. But then the 0, I'm just going to write minus 0 because that's going to cancel out. So this tells me my consumer surplus is $25,000. Let's stay with the fitness watches, but look at the supply function. So the supply function for X thousand fitness watches can be modeled by the function P equals S of X is 0.175x plus 100 for the fitness trackers. How many watches will be supplied at a price of 128? So I'm going to set this up and do the algebra of 0.175x plus 100 equals 128. That says 0.175x equals 28. And I can divide by 0.175. which will give me x is equal to 160. So when we look at this, we need to say how much money does the supplier receive from the sale of the watches? So we're still thinking of the idea of revenue, and it would still be this big box where I take the price times the quantity. It would create this rectangular area. But this time, what we notice is they had an idea of how much money they wanted to make, and that's represented by this trapezoid look that I have the supply function over the area that got me to the 160 watches that we're making. So they had a little bit of extra. There was this amount on top, which is the surplus. The shaded amount in this triangle on top shows the excess they received. So they got more revenue than they had set out to. So they had a minimum amount they wanted. And of course, they're always happy to get more. So we would call that the producer surplus. So the producer surplus, which I will write as PS, is the difference between what producers receive for X items and what they were willing to be paid for X items. We will use P bar for the price paid for X bar items with the demand function S of X. The producer surplus will be P of S equals the integral from 0 to X bar of P bar minus S of X dx. So we're back to thinking again about this as the difference between curves, and you need to look at the fact that P bar is on top and S of X is underneath that. So when I'm doing my subtraction, I'm going 0 to X bar of P minus S of X. So the order makes a difference. We want to make sure that our surplus is always a positive number. So for our particular case, we have 0 to 160 of 128 minus 0.175x plus 100 dx. Now notice this time I did put a second set of parentheses around the supply function. I want to make sure I distribute the negative to both pieces of my function. So now I have 128 minus 100 is 28 minus 0.175x. I need to integrate from 0 to 160 dx. All right, again, just a simple power rule. So 28 becomes 28x. I have minus 0.175 x squared over 2. I put in 0, I put in 160. Let's put 160 through. I have 28 times 160 minus 0.175 times 160 squared over 2. Again, the 0 is going to give me 0, so I'm just going to put that 0 in there as a placeholder. So this gives me a producer surplus of $2,240. As we move further in the problems, I will generally give you either the price or the number of items that are sold. Most of the time you'll be given one, and then you're asked to solve for the other. So let's try this one. Find the consumer surplus when the price is $45, given P equals D of X equals 60 minus 0.125x. So we have a price, 45, which is equal to 60 minus 0.125x. I'm going to subtract 60, which gives me negative 15, is negative 0.125x, and then I'm going to divide by negative 0.125. So this says x is equal to 120. Let's talk about notation. We're going to call X bar 120. We'll call our price P bar 45. Our consumer surplus, I'll remind you, is 0 to X bar of D of X minus P dx. So for our problem, we have 0 to 120, 60 minus 0.125x minus 45 dx. I'm going to combine the 60 and the 45. So my consumer surplus is the integral from 0 to 120 of 15 minus 0.125x dx. When I integrate that, I get 15x minus 0.125 x squared over 2, 0 to 120. I'm going to plug in 120 everywhere. So I have 15 times 120 minus 0.125 times 120 squared over 2. 0 again gives me 0. So what you kind of watch for is if it just kind of looks like a polynomial and there's just x's, the 0 will become 0. If there's an e, if there are things with parentheses, then I would go ahead and plug that 0 in and see what you get. But if it just looks kind of a polynomial, you don't really need the 0. You just put it there as a placeholder. So now I got my calculator. I have 15 times 120 minus 0.125 times 120 squared over 2. and that gives me $900. So my consumer surplus is $900. So let's try another example with the producer surplus. It says find the producer surplus when 280 items are sold, given S of x equals 7 plus 0.05x. So this time we were given x, and we need to start by finding p. So p will be 7 plus 0.05 times 280. This gives us a price of 21. So producer surplus, 0 to x bar for my integral. I put p first, minus s of x dx. So for our problem, our producer surplus is the integral from 0 to 280. P was 21 minus parentheses 7 plus 0.05x dx. So I think it's really important to slow yourself down enough to make sure that you're putting the right numbers in the right place. If you put the price where it is supposed to be the bound, right? Like if you mix them up, your answers are going to come out really strange and maybe even negative. So slow down enough to make sure that you put things in the right place. Before I integrate, I am going to simplify that a little. Let's make that the integral 0 to 280. 21 minus 7 is 14 minus 0.05x dx. All right, so the 14, we're going to give it an x. 0.05 becomes 0.05x squared over 2, 0 to 280. I'm plugging 280 in everywhere. So I have 140 times 280 minus 0.05 times 280 squared over 2, and then minus 0. So I got a producer surplus of $37,240. Market equilibrium occurs when the price that consumers want to pay for an object is equal to the price that producers want to sell the object. So what we find in this particular instance is that the price and the quantity are the same for both the supply and the demand functions. We can find the market equilibrium by setting the demand function equal to the supply function. So let's try that with an example. The price for which x thousand pints of ice cream will be sold is p equals d of x is 6.25 e to the negative 0.005x. The price for which x thousand pints of ice cream will be produced is p equals s of x equals 4 e to the 0.005x. Find the market equilibrium. So we're going to set our supply equal to our demand. So I'm going to set my supply 4e to the 0.005x equal to the demand 6.25 e to the negative 0.005x. I am trying to solve for x, so it kind of says we need to gather all of the x's on the same side. So let's divide both sides by e to the negative 0.005x. Remember, when you divide anything with the same base, you are going to subtract the exponents. So these e's are both the same. So what am I going to do? I'm going to take 0.005x and I'm going to subtract negative 0.005x. That's going to give me 4e to the positive 0.01x. On the right side, I still have 6.25. Now I'm going to divide by 4. So I have e to the 0.01x equals, I'm going to go ahead and make that a decimal, 1.5625. To get rid of e, I need to take the natural log of each side. On the left side, I'm going to get 0.01x. On the right side, I'm going to write it as the natural log of 1.5625 because I know I'm not going to get an integer or a rational. As a last step, I'm going to divide the natural log of 1.5625 by the 0.01. So this gives me about 44.6. Remember, this is in thousands, and so it would be okay to have a decimal when you have something that isn't in an integer unit to begin with. So given in thousands or in millions, it would be completely okay to have a decimal. So let's find the producer and consumer surplus when the market is in equilibrium. I'm going to start with the consumer surplus, and let me remind you that the demand function was 6.25 e to the negative 0.005x. We said we are selling 44.6 thousand pints of ice cream. So let's figure out what d of 44.6 is, which will tell us the price that each pint will sell for. So this gave me $5. I got 5.0007, and we're just going to round that over to 5. So we got this nice value that's p bar. So I'm going to integrate from 0 to 44.6. Remember, I'm going to start with the demand, which is 6.25 e to the negative 0.005x minus my price, which is 5 dx. When I integrate, I'm going to get 6.25 e to the negative 0.005x divided by negative 0.005. We had that little trick for e that said when it was just k times x, we'll divide by k. When I integrate 5, I get 5x. I'm going to plug in 44.6, and I'm going to plug in 0. Now this time, the 0 will not make everything go away, so it's important that you plug it in everywhere. If you want to simplify first, 6.25 divided by negative 0.005 comes out to negative 1,250. That's e to the negative 0.005x minus 5x, 44.6, and 0 as my bounds. This is optional, but it might help with putting numbers in the calculator if you have less that you have to put in. So I'm going to put in negative 1,250 e to the negative 0.005 times 44.6 minus 5 times 44.6 minus parentheses negative 1,250 e to the negative 0.005 times 0 minus 5 times 0. You can put all of this in the calculator at once. If you would like to leave off the 5 times 0 because that's 0, that's fine. You could also look at the negative negative. You can make that positive, so that's a little bit less to put in. I got a total c of x is equal to 26. I'm just going to round it to 2 decimal places, which was 0.86. So let's also do the producer surplus, and I'm going to write on here that s of x was equal to 4e to the 0.005x, and we said our x bar was 44.6, and we already know that p bar is equal to 5. How do I know it's equal to 5? Is because we're in equilibrium, so the price and the quantity will be the same for both consumer and producers. I'm going to find the integral from 0 to 44.6. I first put the price of 5 minus 4e to the 0.005x dx. When I integrate, I get 5x minus 4e to the 0.005x divided by 0.005. I put in my bounds. Just like last time, I can simplify this a little. 4 divided by 0.005 gives me 800, so I have 5x minus 800 e to the 0.005x. So I'm going to start with the 44.6. I plug that in everywhere. And then I plug in 0. So I have 5 times 0 minus 800 e to the 0.005 times 0. So this time, the 5 times 0, this is 0. Again, the negative negative, I can switch that to positive. But you do want to watch to hold on to the 0. Make sure you are subtracting the 800. Then you can combine that to make it adding once you've done all the pieces. All right, so now we go to our calculator, and I get the producer surplus is equal to 23.14. We can have a consumer surplus and a producer surplus when the market is in equilibrium. The producers and consumer surpluses do not have to be the same. You can see we got a consumers, that was 26.86. We got a producers, that was 23.14. What's important is they both have extra amounts that we can calculate.